So this one is again on CCUS, right? And overall, I think the dynamic dashboard architecture with cross asset data fusion for an integrated CCUS value chain monitoring. That is the title. My co-authors Karan and Akshay are also in the session, but there are others, Prem, Dilip, and Sanjeev, that have authored this together. So I'll start with the introduction. And as in the previous session we have spoken about, CCUS really is one key element, right, which supports large scale decarbonization. And overall, especially in sectors where there is a little bit, you know, difficulty in terms of abatement, I think CCUS is the only way out. Overall, as CCUS scales, right, I mean, you'll see that there are different elements or different systems that are there in the entire system. Typically, if you'll see capture, compression, transport, injection, and storage, and these systems are evolving from standalone facilities, and but they are highly interdependent, right? So let's say changes in one system can actually impact or are really dependent on other systems, other part of the connected systems. At the same time, CCUS also, generates diverse data, right? There can be data which is very high frequency, more on the surface side, like SCADA systems or even other sensors that we look at. And at the same time, there are other data that is periodic, or it could be, once in a period. Typically when we are looking at subsurface and inspection data. This makes integration of all of these data elements challenging, right? And this really highlights the need for system level monitoring enabled by a dynamic dashboard platform. Skip to the next one. Overall, in the literature study, right, if you look at it, the CCUS literature has primarily focused on individual systems such as capture, transport, and storage, uh, with limited emphasis on an integrated solution. Most digital implementation remain very asset centric. That monitoring each independent equipment rather than capturing system wide integrations. Overall, this limits the visibility into cross asset dependencies, which are critical in operations. Also, in addition, as we spoke, the data is fragmented, right? Some of the data might be very high frequency, while some data might be very extremely periodic, subsurface and inspection data in particular. Uh, Further, digital twin approaches, right, that are emerging, they are typically domain centric. So some elements will focus on capture systems, while some might look on compression centric assets and things like that. Overall, there is a clear gap for a dynamic integrated digital platform which can monitor the entire CCUS value chain as a connected system. Uh, Overall, in this work, right, we propose a dynamic cross-asset digital platform, which is overall uh, monitoring the CCUS value chain. At the core of this architecture, each asset, such as capture units, transportation pipelines, storage sites, is represented as a configurable digital object. Importantly, the system explicitly captures relationships between these digital objects and also dependencies for forming a connected network model of the entire value chain. We spoke about the differences in the data capture, but the unified data layer integrates both real-time as well as period operational data, which is subsurface and inspection information. Now, based on this connected asset definition, dashboards are auto-generated uh, without the need for any fixed layouts, right? So overall, this architecture ensures scalability and flexibility, allowing the overall digital system to monitor seamlessly the overall physical CCUS as the physical CCUS network expands. Uh, Spending a little bit time on the data fusion and integration, we spoke about real-time data, which is SCADA systems or different servers that we can connect to monitoring data from sensors. And then there is subsurface and inspection data, which could be once every inspection or once every period, right? So overall, due to this diverse frequency of data, capture, it might actually lead to non-coherent analytics. And overall, the data fusion layer actually enables storing all of this data in a uniform data layer that not only allows this temporal differences that exist to be harmonized, but at the same time allows analytics to look at this harmonized data uh, in in totality, right? So this by doing this, we enable cross-domain correlation of insights. So if it could be a compressor problem that is generated due to a inefficient capture system, or a low drop in the flow in the pipeline driven by bad compression system, right? So those cross domain correlations and insights are enabled by this data fusion. Overall, as a result, the operators gain a more complete understanding of the system. This integrated data foundation ultimately supports more reliable diagnostics and performance monitoring. The next element we spoke about is dynamic dashboards and cross asset analytics, right? So data fusion gave you a little bit understanding of how the data is stored together and harmonized so that cross asset analytics can be modeled. But at the same time, dynamic dashboards are very critical, right? I mean, if you overall, as your CCUS system scales, there could be addition of new compression systems, there could be addition of new pipelines, and if you have to spend time on remodeling all of that, building the dashboards, I think that will take away a lot of time, right? So if the as the system increases or scales, is there a way in which we can dynamically update our dashboards? And that is really what this method provides, right? Overall, this allows the system to adapt seamlessly as assets are added. At the same time, operators can visualize the entire value chain or focus on specific assets as they need, but at the same time maintaining full system context, right? Uh, Not only is the dynamic dashboard important to visualize the entire flow from surface to subsurface, but it also allows cross-asset analytics by correlating, upstream as well as downstream operations. This improves anomaly detection and helps distinguish root causes from the entire system. Overall, the approach supports more informed system level decisions based on the environments. I mean, in the results, if you look at it, I think dynamic dashboard generation, right? In the conventional asset versus proposed dynamic dashboard, it is clear that there is high scalability. The asset alerting is fully supported. The value chain visualization, I mean, ability to look at the entire value chain end to end is something which is supported by natively. Asset addition, if you add any compressors, any pipelines, any capture systems, all of them automatically get reflected in the dashboards. And then the dashboard structure itself is dynamic, right? So the ability to visualize anything based on the scale is available by default. Uh, in the cross data fusion, right? I think the key outcomes there are really more from a ability to analyze the entire effects, right? So if short-term pressure deviations that are arising in the transport systems can be analyzed alongside periodic subsurface assessment updates, allowing between surface induced transients and reservoir driven effects, right? Overall, this reduces the diagnostic ambiguity that commonly arises when high frequency data as well as inspection data is viewed in isolation. It overall it also allows a complete end-to-end visualization of uh, point problems that can occur in the entire value chain. So that is really something which is output or a result of a cross asset data fusion. Uh, Having the cross asset data fusion itself, right, it allows you analytics that are not restricted to a particular asset, but can go across the value chain as we mentioned. So overall, there will be two elements. One is the rule-based violation of engineering limits and operational constraints. while at the same time, machine learning will identify subtle deviations and correlated patterns across the entire assets. So this will all be contextualized within the connected asset network, enabling users to visualize the entire propagation paths. So in several evaluated scenarios, anomalies initially detected at downstream were actually traced back to upstream equipment or upstream conditions, such as capture rate changes or compressor malfunction, right? So without this explicit modeling of asset connectivity, such root cause, accurate analysis is not possible, or it is difficult to establish. Uh, in other benefits that we see, right? Overall, better coordination between the different teams, the engineering teams, the operational teams, the field teams. Having this entire connected network will allow this coordination, a better coordination between these teams. System level indicators will provide early warnings, allowing, this will allow maintenance activities to be prioritized based on value chain in the entire pipeline, rather than looking at each asset in isolation. The operators have reported improved confidence, right, in their ability to assess the problems in the entire system rather than looking at each asset at a time. Finally, the dynamic dashboard capability that we spoke about also facilitates communication across different teams, as well as having the common operational picture, right? So subsurface specialists could relate problems having in the surface operating conditions, while the surface operators gain visibility into overall subsurface or reservoir constraints that are existing. I mean, this alignment overall reduced reliance on manual data exchange. So no one had to call each other, but they were able to visualize this value chain entirely. Lastly, so in conclusion, right, this work addresses a key gap in CCUS digitalization, which highlights asset-centric monitoring, which changes the asset-centric monitoring into a system-level approach. This proposed platform models the CCUS value chain as a connected network, which is a more accurate representation of operational dependencies. We spoke about dynamic dashboards generated from this model. We also spoke about data fusion. By integrating real-time and periodic data, the platform improves the overall capability of analytics, as well as prevents misinterpretation. Right? And cross-asset analytics further enhances root cause identification by the entire value chain. Importantly, the architecture is scalable and adaptable as systems scale or they are added. This will allow dynamic addition or dynamic visualization capabilities within the system. Overall, this will enable more reliable, efficient, and future ready CCUS digital operations. That's it. Thank you.